Hello, everyone. You hear me? Okay. I'm Jagor Cakmak, and I work in Erste Group card processor. We are in the business of acquiring your credit cards and moving your data around. So today I will talk about hardware SSL encryption and decryption on the budget. So some small agenda. First, I will talk about some background and motivation why we went into this project in the first place. What is the basic idea and basic idea of the setup, and how we did the implementation, and then what was the testing results, and what issues we had with compliance in this solution. So, some general background. Generally, if you are doing credit card acquirement or anything else which includes cardholder data, you are obliged to follow some standards. And those standards are also, I would say, the best practices in some part, for one of which is hardware encryption and decryption of anything that you can do. So, there's several types of HSMs. Today we are going to talk about the ones that are dealing with SSL TLS connections and not on the payment. Last year I did a talk about how to run HSM farm, full production farm, and that's a huge infrastructure. That's a huge infrastructure from the people's perspective, and that's huge infrastructure from the boxes that you have to be able to run that. So we had the idea, okay, how to scale this down. So what is HSM? HSM is a hardware security module. The basic idea is, well, to keep your keys in a safe place without anyone to read it or copy it in an unauthorized way. You can only ask the device, can you please decrypt or encrypt something, but you can never find out the key behind it. Those devices generally are very expensive. For your lowest end PCI Express card, it's like over 4,000 euros and up, way up. If you have dual site, well, that's at least 8,000 euros. If you're trying to buy a standalone device, that's twice as much at least. So that's a lot of money. You have to service them. You have to have a vendor which will regularly check the device. And the question arises, what about utilization of that? You have to be really big and have a lot of transactions and a lot of traffic going to those HSMs if you're going to utilize these devices in a way that they're built. Because if you do not have a lot of transactions, basically the smallest device on the market will be too big for you. And even in the companies such as ours, on some small part, there are some very specific requirements on some very specific parts of the equipment that, amongst other things, requires exclusive usage of the device for the service. So we went, okay, fine. Your standard box is way too big for us for that small part of the service. We have our bigger boxes for everything else, but we cannot use them. So what we can do? We went on to search on the market. What is else there? So we found this open source little device. It's called Nitro Key HSM. It's basically open source HSM USB stick. It can offload your SSL connections and do hardware encryptions in this little stick. Normal box is like this big, with fans, you have to have rack for it and everything else. So that was like really interesting, and we said, okay, fine, what we can do with that? This little stick can hold your RSA keys, it can hold your ecliptic curve keys. Most importantly, it can talk PKCS11, and it costs about $60. So that's nice. That's cheap. So basic idea was, let's see if we can use this little device for doing SSL TLS encryption on our web service. Starting point, well, this little device, which is open source, that's nice. I always support open source. It doesn't have some big compliance certificates, but it was security audited by Open Technology Fund, and it met common criteria, I think. Probable and expected issue, obviously, speed. This little thing cannot compare to the big box that has a couple of multi-threading processors especially made for encryption. But still, it works. So we said, fine, we will have some web server that will listen on the internet for connections, and when connection arises, it will ask this little stick for the renegotiation of the keys. It will do RSA or elliptic curve encryption, and the rest of it will be done in the server. Okay, that's fine. That's a good idea, but it won't work because if you have some little bit more transactions than, I don't know, 1 per second or something like that, it won't be enough. So we said, okay, fine, we'll buy a lot of them. If you buy 20 of them, that's still 2 times, 3 times, 5 times cheaper than any device. So we will put some proxy in front of them, and we will do round robin of the connections. Okay, that was the idea. So we dig into it, and see, okay, what were the requirements? We found out that basically you can do everything pretty much off the shelf. Some configuration is needed, but not that much. It's not that difficult. There is a guy who did similar thing. So this link will be available on slides later. How to use this key with Apache and mod NSS. The problem is that you have to have ability to communicate PKCS11, and your standard Apache installation uses OpenSSL, which does not have ability to talk with that. So we had to change from OpenSSL to mod NSS, which is basically the legacy Netscape implementation of SSL. There was a question, okay, fine, that's nice, but who runs that? So we asked Kost, and thank you, Kost, if he's somewhere here. Hence he said basically, there's the same, pretty much the same size of the crew that is running the OpenSSL, so yeah, it will be fine. So we continued with that, built the Apache with mod NSS support, and tried to configure the device. So first, I won't go in the full technical details here, but basically your first step is to create your RSA key pair or elliptic curve key pair. That is done on the device itself. The nice thing that this little device has a ability to replicate itself. You can use data encryption key to move data from this little device to another, to another, to another. So we bought actually 6 of them for our test. And we replicated, so they are all the same. They all have the same keys inside. Okay, we then built the Apache web server with mod NSS in front. And to balance it all, we used hub proxy for round-robin communications. Each key is connected to the one virtual host on the same Apache server. And then, actually, the virtual host points to the same application behind, but each application listens on the different port. So a hub proxy will just go 1, 2, 3, 4, 5, 6, and so on. When you see from this perspective, user 1 will get here to one virtual host, user 2 will get to second virtual host, and each time the different key will actually respond. It's quite simple solution and very elegant, because if one key fails, well, 1 of 6 fails, so 5 other transactions will still go on, and you can just shut down that virtual host, and that's it. Actually, you don't have to shut down virtual host, but just on the hub proxy. So out of the box, you have resilience. You have if you have dual side with 6 keys on the one side, 6 keys on the other side, chances of failure are really low, actually, and it's cheap. So testing, it didn't take that much time to build this whole, because you're using pretty much all the tools that are available, and with your standard configuration, apart from the explaining how to communicate with this little stick, but that's standard PKCS11, so that shouldn't be actually a problem, because you explain to Apache to communicate to this stick the same way you would explain to Apache to communicate with the big box, completely the same. They only see PKCS11 interface exposed. We use this configuration. We use TLS 1.1, 1.2. We had 6 Nitro keys for the 6 virtual hosts. This is the elliptic curve cipher suite and RSI cipher suite. Okay, unfortunately, in the banking business, we're not that advanced. So there was a big issue about supporting elliptic curve keys. RSI keys obviously are supported, but we said, okay, fine. We have 6 keys. Let's see. Let's stress test the system and see what we can get out of it. So we used stress testing environment for the 2048-bit key and 25 concurrent users. We went, okay, our percentage of availability is 98.87% for all transactions. That's pretty okay, actually. And we got somewhere, about 22 actually transactions per second max. Then we say, okay, that's nice. Let's move on. Then we moved for 50 concurrent users. Yeah, but then we didn't meet the criteria. We had only 90% of the responses. The answer in production would be, okay, fine, let's buy more keys. It will work. The fun part, okay, you see also here that if we just move up the concurrent users, that we will lower the availability. But the test showed that actually, well, you can plug more keys, the availability will be higher. And it's because it's so easily scalable solution, that is not a problem. But the great part, actually, if you use elliptic curve keys for the 100 concurrent users, we got, I don't know, more than 30 or 40 transactions per second with just little those keys. That's something that you would get out of the big box, actually. That would cost like 5,000 euros or something like that. So yeah, it worked. It didn't take us that long, actually. It took us long just to go for say, okay, we will test this. We invested some money, obviously not that much money, but it worked. And then the bad. Compliance, because we are obligatory to be compliant with a lot of standards. Amongst other things, it was said that all key management must be performed using an HSM. At minimum, these activities include all key generations activity, storage of clear keys, all translations, encryption, decryption. Okay, fine. Key is safely stored. If you move keys from this little key to another, it will be encrypted with the local key. That's all good. But if you roll out the standard more, the definition of HSM, it says that HSMs must be certified by FIPS level 3. And this is where it fails. Actually, in the end, it failed in the part of the where you have to generate the key, because this is not compliant. You have to generate the key on the compliant device, and there is no way to completely move that RSA key from your compliant device to this little one, so it will be the whole process will be compliant. But once the key, the RSA or elliptic curve keys are on this device, then it will be okay actually. So if you do not have to meet those PCI or high Visa standards for high security, this will work. If you are a web shop that is not Amazon, that if you're not having thousands and thousands of users per day, I don't know, 12 of those keys will work, and you can run your RSA keys, your SSL certificates inside of those for in a very, very secure way, way more secure than any software version of storage of data. It's open source, it works, and it's cheap. And this is how the setup looks. This is our 6 keys with a small USB hub connected to the server, and that's it. Further development, in this case, which we didn't make it, is how to make it to work with virtualization. When we tried to connect this USB hub to the virtualized environment, that translation didn't work. But I think that from my colleague's perspective, at least, that's not that hard to work, but we didn't explore it further. So conclusion, well, it works, it's cheap, it's very resilient, it's more resilient than probably 1 or 2 big boxes of HSM that we will buy for 10,000 euros, but it's not compliant for all purposes. If you do not require full compliance, then it's probably interesting options to check out. And it's a really great alternative. Before questions, well, big thanks to actually colleague that did most of the work on this, Tomislav Živković. He wasn't able to take to the conference, and to Kost that did help with mod NSS integration. So, any questions? Yes. Okay. The audience asked that if there is something that my company can do to make this compliant. Well, I guess so, but it would cost us a lot of money. Basically, the reason this is not compliant is because the FIPS compliance costs way too much money, and this is open source project. Yeah, the only issue. Oh, this more. Okay. So, any more questions?